Welcome to class once again. You're welcome to the O3 School app. All right. Remember, this video is brought to you by the O3 School app. And the app is of two kinds, the JAMB app and the WAEC app. All right. If you're a first timer, if you're just new in terms of following us, just know that the app is quite available in the Apple Store or Play Store. So do well to subscribe, share, like, and also install the app, activate the app, so that you can have license to several subjects. All right, physics, chemistry, biology, government, they are all there for you. All right. Okay. In today's physics class, we'll be talking about heat transferred. Now, when we talk about heat transfer, it simply means the exchange of heat from one body to another. So if we remember Clausius' statement in thermodynamics, Clausius told us that heat is being transferred from a hot body to a cold body. Now, those are laws in thermodynamics because thermodynamics is an unarguable science, or is an axiomatic science. It's a science that you cannot argue, all right? That deals with heat transfer in a material system, all right? Heat transfer, energy conversions in a material system. Now, we have heat transfer. Now, heat transfer, let's see what we have here. So heat transfer is a process by which thermal energy moves from one object or body, other object or body, all right, to another with delta theta. All right. So what is this delta theta here? The delta theta is change in temperature. So we have changes in in temperature. All right. So heat transfer is a process by which thermal energy moves from one object or body to another with change in theta. That means with change in temperature. So for example, we have hot body and a cold body. All right. So when heat is transferred from that hot body to cold body, all right, at different temperature, because remember, temperature is the hotness or coldness of a body. All right. Now, the first body is the hot body. The second body is the cold body. All right. So you see, there is temperature variation. That's why we say there is a change in temperature. So let's assume the cold body. Let's say the cold body was initially at, let's say at 16 degrees Celsius. All right. Then the hot body is at 100 degrees Celsius. So there will be heat transfer from hot body to cold body. All right. Now, when the heat is transferred to this cold body, if they attain a thermal equilibrium, that means they will have the same temperature. All right. All right. At thermal equilibrium, the both body will be at the same temperature. I think that was also explained in thermodynamics. Those of you that will do mechanical science in the university. Now, in thermodynamics, there's what we call the zeroth law, or the zeroth law. The zeroth law. The zeroth law of what? Thermodynamics, whereby we have body A, body C, and body B. Now, if this body A and body B, they have the same temperature and they are being brought close to this body C, at thermal equilibrium, they all have the same temperature. So that means there is heat transfer. Now, one thing we need to know again is that now when heat is transferred from one body to another body, what happens is that if it's a metal, for example, metal, they get heating up immediately because of the fact that they have low specific heat capacity. All right. Then the electrons in metals, they are freely to move. All right. Immediately heat is applied to metals, the electrons in them or the molecules in them, they are excited. So because they are excited, what happens? They migrate from one point to what? Another. They migrate from one point to what? Another. And that gives rise to the heat transfer. So there's a kind of exchange of heat energy. All right. And that gives rise to heat transfer. Now, we also know that heat is the internal energy of a system, of a material system. And heat occur as a result of temperature differences. Of course, there's a temperature difference. All right, from 100 degrees Celsius, heat is transferred from 100 degrees Celsius to 16 degrees Celsius. Definitely, there's a change in temperature. All right, so there's a temperature differences. All right, so there's a temperature difference. Now, we have modes of heat transfer. Mode of heat transfer. All right. When we talk about the mode of heat transfer, that means the mechanisms. All right. The mechanisms of heat transfer. Mechanisms of heat transfer. Now, what are these mechanisms? All right. The mechanism of heat transfer, we have conduction, all right. We also have convection, all right. We have conduction, convection. Then we also have radiation. So we have conduction, convection, and radiation. Now, this radiation occurs mostly in electromagnetic waves. It occurs in electromagnetic waves like the X-ray, all right? The X-ray, nuclear electricity, all right? Then for the convection, this convection occurs in fluid, all right? It occurs, convection occurs in fluids. Fluid like what? Liquid and gases. So convection occurs in fluids, so liquid and gases, while conduction occurs in solid. Now, for example, let's assume that if I have, let's assume I have something of this nature. Let's say this is handle. All right, let's say this is a pot. Then there is a gas burner supplying heat, all right, to this system. Then I have maybe food molecules or water molecules. So what happens is that at the handle of this pot and the walls of this pot, what takes place is conduction. Then here we have radiation. All right, because there will be a radiation of what? Of heat through the burner. Then at the internal surface All right. The molecules of food, the molecules of this food, they undergo what? Convention. All right. So convention occurs in the fluid inside the pot. Now, the entire surface of this pot is undergoing conduction as a result of what? Radiation. So there's those, these are the means of heat transfer. So we have what? Convection, radiations, and what? And conduction. All right? So convection occurs in solid. You are heating maybe metals. What happened? There will be an actual movement of the molecules, all right, or the electrons in that metals. They will be vibrating, and when they vibrate, they translate. All right? Then this one occurs in gases or fluid. All right? When there is circulation of warm air in a room, it's as a result of what? Convection. That is gas. Or when there is circulation of cold air as a result of air conditioning system. All right? That is also convection, either in a room or in a vehicle. Now, radiation. For radiations, you are talking about a vacuum, all right, a free space. That is electromagnetic inductions. Because in waves, we have what we call the radio waves, all right? Signals, radio waves is mostly based on telecommunications. It's mostly based on what? Telecommunication, where messages and signals are being conveyed or transmitted through a very long distance. So there is need for what? Electromagnetic waves. Now, in electricity, there's what we call the nuclear power. The nuclear power is as a result of radioactive material. So this radioactive material, they undergo what? Radiations. They radiate heat, very much heat. Then the X-ray, all right? The X-ray can be used in treatment of either cancers or bones because they emit light, or they emit what we call the photons. So these photons can penetrate through the human structures, all right? The human tissues, the human system, they can penetrate and display the internal images within the human system. So we have the radiation, the conductions, and the conventions. All right. Now, what are the okay, I've said that the radiation can also be used in food preservative. All right, food what? Preservative, like smoking of food. It's on those like fish roasting. They undergo what? Radiation. By so doing, it will prevent or preserve food. All right. I've also talked about the energy generation. The another thing is cancer treatment. That is radiotherapy. The radiotherapy, they use these radiations for what? For cancer's treatment. Not just that, material thickness. If you want to know material thickness, the use of radiations can also be applied. All right. Okay, so let's see. Now, there's another concept that we need to see. Let's see here. Okay, now heat transfer. All right. Now, conduction is a movement of heat energy. All right, or is a movement of thermal energy. When you hear the word thermal, all right. So conduction is the movement of heat energy or thermal energy, all right, whereby the molecules or the atoms of that substance undergoing, maybe like this pot, the molecules of this pot undergoes what? Radiations. Now, because they undergo radiations, what happens is that the particles, they will start migrating. By the time the particles start migrating, what happens? There will be a collisions among the molecules. There'll be what? Collision. And because of that collision, the particle will start migrating. Same applicable with the molecules. If it's a water molecule, At high temperature, what happens? The molecules of water will also be what? They'll be vibrating and be hitting the walls of this container. So typically, state of matter that have loosely atomic or molecular electrons are good conductors of heat. In terms of electrons, a little application of heat on metals, they emit electrons, and that is called thermodynamic emissions. So what happens? Electrons will be migrating, they will be translating from one point to what? To another. All right. So that's the major reason why metals, they are good thermal conductivity, because they lose their electrons freely under the application of what? Of thermal energy or heat energy. So most metals are good conductors of heat, while wood, paper, glass, they are examples of poor conductors of heat. So the glass, they are what? Papers like this, they are poor conductors of what? Of heat. So take note of that, that conduction is the movement of thermal energy by collisions of atoms and molecules. All right. Now I said we can also have that. Immediately we have cold water, or let's say if we have hot tea inside a steel cup, what happens is that heat, all right, heat will be transferred from the tea to the surface of the cup. That is why you felt hotness. The reason is that metal is the steel has what? High thermal conductivity. So metals, they have very high thermal conductivity. All right, now I said conduction. The heat from the coffee or tea is transferred to the cup that you are holding. So what happens is that the surface of the cup becomes so hot and what? Radiating. All right. What happens? Electrons are used as a result of heat. Now, initially the cup is cold and you are placing hot substance inside the cup. Heat will be transferred from that hot material to the cold material, and that was stated by Clausius. So in thermodynamics, Clausius' statement told us that heat is being conveyed or is transferred from what? From hot body to cold body. All right. Then there's what we call the thermodynamics. All right. Let's see. There's what we call the thermodynamics. 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 I also have the first law. All right. The first law. Now, when we say thermodynamics, now the dynamics is talking about movement. All right, movement. Then here, the thermal is called heat. So thermodynamics from the Greek word can be translated to heat movement or heat transfer. And the thermodynamics have several applications. You talk about the aerospace and engineering. You talk about the combustion engines. They undergo what we call the thermodynamics, because there's always heat movement. All right. Even your kitchen utensil, your pot, your spoon, they undergoes thermodynamics. Your phones, they are thermodynamic because there's heat transfer. All right. Even the human system undergoes what? Thermodynamics. So thermodynamics is an axiomatic science that deals with heat transfer, that deals with what? Heat movement. All right. And energy conversion in a material system. Now, our major focus is the first law of this thermodynamic, because we're talking about heat transfer. Now, for the first law, we know that from the law of conservation of matter, all right, that energy can neither be created nor destroyed, but can be converted from one form to what? Another. So that implies that for the first law, it means that the heat gain is equals to the heat lost. All right. Now, heat gain. Definitely the cold body will have heat gain. All right. The heat loss is from the hot body. The hot body. Because from Clausius' statement of thermodynamics, he said heat is being conveyed from hot body to a cold body. So definitely the hot body will lose heat. And heat will be gained by the what? By the cold body. So the first law of thermodynamics tells us that heat gain is equals to heat loss, because energy can neither be created nor destroyed, but can be converted from one form to what? Another. From one form to another. So that is what the second law of what? Thermodynamics. So heat transfer is a fundamental concept with the field of thermodynamics, with this with the movement of heat between systems. You talk about combustion engine, your vehicles, there is always heat what? Movement. That's why they said heat dynamics, thermodynamics. All right? There's, let's assume a generator that works for, a generator is also a thermodynamic system, because there's energy conversion from mechanical energy to electrical energy. Then there's also heat what? Heat transfer. There's heat transfer. Because of the rotation of the rotor of or the armature of a generator, what happens is that heat is emitted. All right? Heat is what? Heat is emitted. So heat is a fundamental concept within the field of what? Thermodynamics. Okay, so let's see again. We've talked about convections, radiations. Then there's what we call the basic formula for heat transfer by conductions. So let's see. Basic formula. Let's say, for example, we have this block. All right. Let's say this is, there is heat, supply heat. So let's say this is block A, and we have another block. So let's assume this is block B. We have block A, block B. All right. Now, this is, let's say this is at 120 degrees Celsius. And this was initially at 40 degrees Celsius. So there is heat flow. All right. There is heat flow. Now, if this body is brought close to this body that is radiating at 120 degrees Celsius, so some heat will be transferred to this. Some heat will be transferred, but let's say this is at 27 degrees Celsius, maybe at room temperature. All right. Now heat will be transferred from body A to body B. Now, as time goes on, body A and body B, we have equal temperature. All right. At that point, they are at what? Thermal equilibrium, heat equilibrium. So we can have block like this. All right. If they are so close, so we can have something like this. All right. So A and B, they are now close. It means they are now having, let's say they are now having the same temperature, because definitely there will be heat gain here, while here there will be heat loss. So let's assume they are now at 90 degrees Celsius, because some heat will be lost from here, and this one will gain. This is 27. All right. Now, what happens is that if these two, they are now in the same temperature, it is called the thermal what? The thermal equilibrium. All right. So now this process is through conduction. This process is through conduction. So we said the formula for heat transfer, the formula for heat transfer by conduction, Q equals to minus K A delta theta over delta X. All right. Some textbook will tell you minus Ka delta T over dx. All right, because I think delta T over the S, that's temperature gradient. All right, so this Q here, the Q here is the heat transfer. The heat transferred. All right. So Q here is heat transferred. Then K there is the cross-sectional area. If I were to consider the area of this cube, all right, area, all right. So A, let's say this is a cube, all right. Okay, for cube we talk about volume. Then area, now area you're talking about one of the face, which is length, 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 and the area is length times breadth. If one of the face is heat, we are considering a small length, all right? Considering one of the face, all right? For one of the face, area becomes length times length, all right? Length times length. So A, that is the cross-sectional area, the cross-sectional area. Then maybe delta X is thickness, all right? The thickness of the material, and is in meter. Thickness of the material in meters. So now, the K there is the thermal conductivity. Now, what is thermal conductivity? The thermal conductivity of a material is the ability of that material to conduct heat. So we now see that materials, they have different thermal conductivity. The thermal conductivity of metals is different from the thermal conductivity of fluid, like water. All right? What happens is that at high temperature, metals will conduct faster. Because if you talk about the thermal conductivity of maybe metals like copper, aluminum, wood, and maybe other materials. Now, what happens is that silver has more thermal conductivity than copper. And copper also have higher thermal conductivity than what? Aluminum. So every numerous metals, they have different thermal conductivity. So the thermal conductivity of a substance or of a material is the ability of that material to conduct what? To conduct heat. All right? So that is why metals are used as pots. All right? If you check most of our kitchen utensils that require heat, they are made up of metals. Aluminum pot, you can have the steel pot. All right? I know the steel pot is an alloy of two or more metals. So what we are saying is that the pots are metallic because they have higher thermal conductivity. All right? They have high thermal conductivity. They conduct heat very sweet and what? And fast. All right? So this is conduction. Remember that conduction occurs in solid, while convection occurs in fluid, like liquid and what? And gases. I mean, liquids and gases. So that is fluid. The radiations occurs in a free space, which is the electromagnetic wave. All right, those of you that are WAEC and JAMB students, you have done electromagnetic waves. Because electromagnetic waves, they are waves that do not require material medium for their transmissions. All right, for their transmission or for their propagations, they do not require any material mediums, unlike the mechanical wave. All right, because we have two classes of wave: the electromagnetic waves and the mechanical wave. The mechanical wave, they require material medium for their what? For their propagations. So materials that have low specific heat capacity, they have higher thermal conductivity. So we know that metals, they have low specific capacity. That's why they heat up very fast. So because of low specific capacity, that also guarantees them what? Higher thermal conductivity. All right? So let's see. Okay. All right. Now, there's another applications again. All right. There's another applications. We talk about um, the radiations. Now, for radiations, there's this popular question that is mostly asked that the tankers, those tanker drivers, the tankers they drive, what happened is that it is coated with silver painting. All right. The reason why because what they are carrying is highly inflammable fluid, which is the petrol, what you call the fuel. All right. That substance is highly what? Inflammable. That's why you have chains beneath the truck. Now, that chain convey heat. Now, heat is coming as a result of radiations. From radiation to what? Conductions. And from conduction, you have what? Convections. All right? Of which the convection might be so minute, though. All right? Now, as a result of that radiation, the body undergoes conduction. So metallic chains are placed beneath the truck so that those charges, the heat in form of charge, goes beneath the ground so as to avert what? Explosions. All right. So the materials, the silver, the tanks are coated or painted with silver colored so as to what? Prevent explosion. So the charges that are coming as a result of radiation leading to convection and conductions, what happens? Will be transmitted through the what? The chain to the earth or to the ground. So take note of that as one popular JAMB and WAEC questions. All right. So we talk about the mode of heat transfer. Let's also see questions from our app. Questions from app. All right. So one thing you need to know is that from thermodynamics, you may be asked, what are those thermodynamic systems? All right. The electric bulb, any system that require heat transfer, even the human body, is thermodynamics. Aeroplane, they are thermodynamic. The ship, they are thermodynamics. So also note that heat is being transferred, all right, as a result of temperature differences. The heat is also transferred because our heat is transferred from hot body to a what? To a cold body, as stated by Clausius. All right. So it is called Clausius statement in thermodynamics. Also remember that materials that have low specific capacity like metals, they have higher thermal conductivity. All right. They have higher thermal what? Conductivity. That is the K in that formula. It's called the coefficient of thermal conductivity. All right. Which is a Q equals to minus Ka delta theta dx. All right. So that we can have that K is Q dx. All right. Over A into theta 2 minus what? Minus theta 1. All right. This is how to determine the thermal conductivity of a material. So this is called the thermal conductivity of a substance. Either a substance or a what? Or a material. So heat energy is the exchange of heat, or is the exchange of thermal energy, or heat transfer is the exchange of thermal what? Energy between physical systems, all right, driven by temperature differences. So for heat transfer, in fact, for heat to occur, there has to be temperature differences. Now, for heat transfer to occur, there has to be temperature what? Differences. Either from a cold body, from hot body to a what? To a cold body. All right, so it flows at higher to cold body. So the mode and mechanism, which I've explained earlier, the mode and mechanism, we talk about the radiation, the conductions, and the convection. All right. Okay, then for the radiations, I told you they are mostly what? Electromagnetic. They are mostly electromagnetic. So let's see question from our JAMB app. Right? From our JAMB app, let's see question. All right, so let's see. What do we have? Okay. Let's see what we have. Okay, so we have this question. Okay, yeah, another thing we need to see again is before the JAMB question, let's talk about the land and the sea breezes. All right, the land and sea breezes. Now, in terms of conduction, the land absorbs heat. As a result of radiation, when there's radiation to the ground surface, what happens is that the land absorbs heat. So during the day, you talk about the land breezes. Now, during the day, as a result of high radiation, the land becomes warm, so hot, while the sea becomes cold. All right, that's why most times when the weather is hot, most persons try to visit one or two swimming pool, all right, to get their body cold. Now, what happens is that at high temperature, the land is a heat absorber. So the land absorbs heat, all right? But at night, what happens? The land loses heat. Remember that heat loss is equals to heat gain. So the land loses heat. What happens? The sea becomes warm, right? While the land becomes cold. So that is land and sea breezes. So let's see. Let's see a question. It said 1990 question 16. It said, which of the following statements are correct? One, land and sea breezes are natural convection currents. Yes, they are also called, the land and sea breezes, they are natural convection currents. That's correct. Two, convection may occur in liquid or gas. Yes, convection may occur in liquid or gas. For example, when we talk about the molecules of water inside the pot, you are trying to boil your Dioscorea species. All right, so you need what? You need the molecules of water to reduce the breakage percentage. All right, so it could also be gas. Then three, let's see, that's point two. Point three said the vacuum in a thermal flask prevents heat loss due to convection only. No. So the correct answer there from JAMB 1990, question 16, the option there is A. Land and sea breezes are natural convection currents. This statement is correct. All right. So land and sea breezes are perfect example of natural convection. So during the day, the land heat up faster, which I said. The land heat up faster, it absorbed it. So the correct answer there is A. Then 2019, question 27. It said, in the molecular explanation, it is transferred by dash. It's by the molecules. All right, without being told, we've said that before, the molecules. All right, so A, free electrons, B, free atoms, C, free molecules. So the answer there is C, free molecules. Because from the kinetic theory, what happened? In the molecular explanations, it is transferred by free molecules. All right, remember those molecules at high temperature, they engage in collision because they have gained velocity. And why is it that they gain velocity? Because they have gained higher kinetic energy. Because kinetic energy is directly proportional to what? To temperature. The more the temperature, the more the kinetic energy gained by these molecules. All right. So the correct answer there is C, free molecules. All right. So when molecule is heated, it starts to move and vibrate faster. These molecules, they then bump into each other. All right. For example, like the water molecules. All right. By the time the water gets to 100 degrees Celsius, what happens? The molecules of the water, they will bump into each other. They'll start hitting the walls of the containers. So the correct answer there is C. Okay. Now another question there is JAMB 2017, question 36. All right. It said, which of the following concepts is a method of heat transfer? Does not require a material medium. Oh, we've said that before. All right. Which of the following concepts is a method of heat transfer that does not require a material medium? All right. The correct answer is radiation. Radiation does not require any material medium. It's just a free space. All right. So example is what? The electromagnetic waves. Talk about the radio waves, the gamma rays that use the photons. All right. Electrons, emissions from light. So A, conduction. B, radiation. C, diffusion. So B is the answer. Radiation is a method of heat transfer that does not need or require a material medium. It is the emission of energy as a result of electromagnetic waves. All right? Especially at high energy particles, causes ionization. All right? What is ionization? Ionization is what? Emissions of electrons from hot metals. All right? Emissions, librations of electrons from hot metals. Now, 2013, we have 2013, question 24. It said the mechanism of heat transfer from one point to another through the vibrations of the molecules of this medium is dash. All right? Let's see again. The mechanism of heat transfer from one point to another through the vibrations of the molecules of this medium. All right? So that is conduction. That is conduction. All right? The mechanism of heat transfer from one point to another through the vibration of the molecules of the medium. That is conduction. So conduction is a process by which heat energy is transmitted through collision between the neighboring molecules. In solid, these particles are closely packed. Remember that the molecules of solid, they are closely packed. All right? While that of liquid, they are freely packed. All right? While that of gases, they are far from each other. They are far from each other. So that's why the force of the intermolecular forces that is binding the molecules of gases, they are far from each other. All right? They are so far from each other. While that of liquid, they are freely packed. Then what that of solid, they are closely what? They are closely packed. All right? So when metals are heated, what happens is that the molecules of these particles, they collide with one another and they start vibrating. All right? So the mechanism of heat transfer from one point to another through the vibration of the molecules of this medium is termed conduction. Okay, so let's see another question. See another question. All right, this one is 2017, question 37. It said an iron spoon placed inside hot tea becomes hot. This heat transfer is due to dash. All right? For example, you are trying to warm your food and you have a metallic spoon inside that pot. All right? At high temperature, the spoon becomes hot also. The reason is that the body of the surface, the walls of the pot is hot. Definitely the spoon will be hot. There will be heat transfer. And that process is called what? Conduction. All right, so let's see options. The same applicable to iron spoon placed inside a hot tea. Becomes hot. This heat transfer is due to evaporation? No. Evaporation is not a mechanism of heat transfer. So B, conduction, C, radiation, and D, convection. So the correct answer there is conduction. So iron spoon placed inside a hot tea becomes hot due to what? Due to conduction. Due to conduction of heat from the tea through the surface of the spoon. The reason is that metals, they have low specific heat capacity. So because of low specific capacity, they have what? Higher thermal conductivity. So they can conduct heat very fast because they have low specific heat capacity. Now, this is possible because the material of the spoon is a good conductor of heat. A material that has good conductor of heat it means it has a very higher thermal conductivity. Okay, let's see another one. 2017, question 22. All right. It said the silvery surface of a thermos flask prevent heat loss by radiation, conduction, convection, evaporation. You place food inside a flask. All right. What happens is that there will be a kind of radiation. It is that radiation that will now causes conduction within the surface. All right. So it will prevent heat loss by what? By radiation. That's just it. To prevent heat loss by radiation. So the answer there is A. Now the silvery surface of that flask prevent heat loss by what? Radiation. So the shiny and silvery surface reflects the heat. All right. It reflects the heat into the liquid, reducing heat loss. This is why many thermal containers, they have shiny surface. All right. So it will reduce heat loss by radiation. Then we have 2019, question 31. It said heat may be transferred by conduction, convection, and radiation. By which of these methods does heat travel through vacuum? All right. We've said it before. Vacuum is a free space. So it's by radiation without even being told. It's by what? Radiation. So we have conduction only, convection only, radiation only. D, all this method? No. The correct answer is C, through radiation only. All right. So heat transferred in a vacuum. Heat transferred in a vacuum is by what? Is by radiation only. Is by radiation what? Only. So when you talk about vacuum, talk about free space. All right. So free space, they undergo what? Electromagnetic waves. Examples of electromagnetic waves can have our radio waves. So the correct answer there is C, radio waves. Okay, now another thing is 2017, question 10. Question 10. It said a person in a room feel cooler under a rotating fan because the fan dash. All right. A person in a room feel cooler. The reason is that there's a relationship between coldness and evaporation. All right. Because evaporation causes cooling. Evaporation, what happens is that the heat from your system is being evaporated from your body, and that causes cooling. All right. So A, lowers the room temperature. B, increase the rate of evaporation from the skin. C, reduce the relative humidity in the room. And D, blows cooler air to the skin. Is to increase the rate of radiation from the skin. So what happens is that it will increase the rate of what? Evaporation, because evaporation causes cooling. So the skin feels cooler as a result of evaporation from the surface. I've said that before. Evaporation causes cooling. So a person in a room feels cooler under a rotating fan because the fan increases the rate of evaporation from the skin. So the correct answer is B. All right. So 2010 JAMB number 10, correct answer is B. Okay. Now I have 2018 question 36. It says heat reaches the food which is being cooked in a saucepan chiefly by what? All right. I have a pan. There's heat. All right. Now, if I hit this surface, all right, immediately heat touching this surface is by conduction. All right. This one is by what? Is by radiation. All right. Now, the food here, all right, heat will get to this food by means of conduction. Heat is only getting to the surface of this pot by what? By radiation. But heat is getting to this food by what? By conduction. So after conduction, before convection. All right. So we have A, conduction and convection. B, conduction and radiation. C, convection and radiation. No, the first approach is that there is radiation. Now, from radiation, we have conduction. Then from conduction, we have convection. So heat we get to the molecules of this food by what? By conduction and convection. It is only the surface of the pot that undergoes what? Radiation. All right? So radiation, there's emissions of heat. Now, immediately there's emissions of heat, what happens? The pot is made up of metals. So electrons will be migrating. Immediately an electron migrating, there will be what? Ionization. And once there's ionization, there will be loss of what? Electrons. All right? So the correct answer there is A, conduction and convection. So heat flow through the wall of the saucepan is by conduction, and the different part of the food is by convection. So remember that convection only takes place in fluid. All right? In fluid, you talk about gases and what? And liquid. All right? While conduction, in conduction, you talk about solid. All right? Talk about solid. While radiation is free space, which is vacuum. So for free space, they don't need material medium for their emissions or for their propagation. So a very good example is electromagnetic waves. So electromagnetic waves undergoes what? Radiations. So the correct answer there is A, conduction and convection. Okay, so let's see. Lastly, we have another problem here. Okay, so let's see what it's all about. All right. Now, a question will be asked, why is it that plastics, rubbers are not used as cooking utensils? All right. The reason is that these materials are insulators. You can't be using a rubber pot. Say you have a rubber pot in cooking. No. All right. The reason is that those materials, they are poor conductors of heat. All right. Those materials, they are poor conductor of heat. So that means that a material that has poor conductivity, it means it will also have poor thermal what? Conductivity. So metals are used. Metals like the steel, aluminiums, and what? We talk about the aluminium, all right? The steel pots. They are used for cooking. They serve as maybe kitchen utensils because they have higher thermal conductivity. That is one. Now, the second thing you need to know again is that a material that have higher thermal conductivity, they always have low specific heat capacity. All right. So material that have low specific capacity, that means that they normally have high, their temperature rise very fast when there is heat changes in that material. All right. So when they are subjected to high temperature, electrons in them, they migrate very fast. All right. So let's see this problem. This is JAMB 2007. 2007 question 36. All right. You say a blacksmith. Remember blacksmiths. These are persons that are engaged in forging. All right. Beating of metals. So a blacksmith heated a metal whose cubic expansivity. All right. We've done this before. Cubic expansivity is 6.3 times 10 raised per minus 6 Kelvin inverse. All right. So a blacksmith heated a metal. So remember that when you heat metals, they are subjected to what? Expansion. At high temperature, metals undergoes expansion. But at low temperature, they come back to their normal shape as a result of what? Contraction. So we have contractions and expansion. So now the area expansivity. This is gamma. Gamma talks about cubic expansion. In the previous video, I told you that the cubic expansivity is the increase in volume per unit volume for every degree rise in temperature. Now, there is a relationship between linear, volume, and area. All right. So in this question, they say the area expansivity is dash. So that means area expansivity, area expansion is unknown. We don't know. But the volume expansivity is given. So there is a relationship, which we said when we were discussing on expansion. If you follow the videos from the beginning, remember that area expansivity is 2 times the linear expansivity. And the linear expansivity of a material is the increase in length per unit length for every degree rise in temperature. So when you are heating metals, because they have higher thermal conductivity, they will undergo what? Expansions. All right? So for gamma was 3 what? Alpha. All right? Now in this case, if alpha, gamma is 3 alpha, and they said we should look for the what? The area expansivity. So we can do a relationship. We can deduce. So what do? We know that alpha will be what? Gamma over 3. All right? Alpha, from here, from this relationship, alpha will be gamma over 3. So I can come back and say, okay, beta is 2 alpha, and alpha is gamma over 3. So I'll have gamma over 3. So from there, you see the relationship. So definitely my beta becomes 2 times gamma. Gamma is the volume expansivity of that metal, which is given to be 6.3. Let me erase this over 3. So this is 6.3 times 10 raised to power minus 6 Kelvin inverse over 3. All right? So that means that if we do that, beta is giving us about, let's use our calc. So if I have 6.3 times 2, okay, that is 12.6, all right, times 10 raised per minus 6 over 3. So let's come a bit. So beta is 12.6 times 10 raised per minus 6 over 3. All right. So 3 will go into 12 4 times. 3 will go into 6 2 times. So that's about 4.2 times 10 raised per minus 6. All right. So Kelvin inverse. Kelvin inverse. So remember, both the linear, the volume, they are both measured in what? Either Celsius inverse or Kelvin inverse. So let's see the options. Okay, so the correct option there is B. All right, is B. So a blacksmith heated a metal whose cubic expansivity is 6.3 times 10 raised by minus 6. So the area expansivity, all right, this is area expansivity. So when you heat a material, what happens? The material undergoes area expansion. All right, increase in area per unit area for every degree rise in temperature. But if you are heating fluid, there will be increase in volume of that fluid. Because we're made to understand that from anomalous expansion of water, between 0 to 4 degrees Celsius, water will contract, and that will reduce the volume. So above 4 degrees Celsius, what happened? The volume of water will increase. So that means increase in volume per unit volume for every degree rise in what? In temperature. All right, so the correct answer is B, 4.2 times 10 raised per minus 6 Kelvin inverse. Okay, just a recap before I end the class. Heat transfer. All right, heat transfer occurs as a result of what? Temperature what? Differences. All right, now the reason is that heat is conveyed or transferred from hot body to what? To a cold body. That was stated by Clausius statement. And I also explained to you that in the first law of thermodynamics, because the thermodynamics is talking about heat movement. The thermo there is the heat. The dynamics there is the movement. So thermodynamic heat movement is the transfer of heat in a system and the energy conversion taking place in that system. All right. So we are also made to understand that the heat gain is equals to heat loss. The reason is that from the first law of thermodynamics, because energy can neither be created or destroyed, but can be converted or transferred from one form to another. So that's why you see the heat loss is equals to heat gain. So if you pour the hot water into a cold water, what happens? The hot water will lose heat while the cold water will gain heat. There's never energy Energy created or destroyed. Rather, they are being converted from one form to another. I will also make some reference to the mode or mechanism of heat transfer. What are these heat transfer? We talk about what? The radiations, the convection, and the what? And the conduction. All right? Thank you. If you don't understand, do where to place your comments, do where to place your issues on the comment section, and do where to also watch the video for multiple times so that you'll be able to comprehend. I wish you good luck.